Hello, the third part, the final part of this video, where we're just going to talk a little bit about some of the reasons you would use a sentinel node. So an sentinel node in general is a broader part of what we would call encapsulation of a linked list, right? And what we mean by that is when we create a linked list out of, for example, int lists, let's say we have one called L that has, some elements like 1, 2, 3, like this. What are the actual objects basically here? There are 3 objects, right? It's this, and this. Each one of these int lists is an individual object in its own right? It has an item and it has a next, basically. So what you'll notice is that we have a bunch of different objects here that all serve a common purpose, but there's no broader class for them, right? There's really no such thing as a linked list in the abstract. There's only nodes, and those nodes are connected to each other. So organizationally, we just kind of have a bunch of pointers everywhere. One of the reasons we create a sentinel node is it allows us to go a level up, basically. It allows us to have now basically an int list class that's pointing at a sentinel. Let's just say this is the sentinel with a value 0. It's like a dummy value here. This is basically the sentinel. And now, yes, these are all instances of a particular class, but the sentinel basically belongs to a broader class as a whole. So if you've seen an implementation of an encapsulated linked list, there will be like a linked list class, and then we'll have a class inside of it that's the individual nodes, right? So we have 2 classes here. This gives us control over the entire class, basically. It helps us organize things. And now let's say we want to write a method that takes in, that does something to this linked list, like we want to do the skip method we just did earlier in the worksheet, or we want to reverse the list, something like that. We can just write it in this broader linked list class instead of having to write some class just somewhere, outside of the other classes that takes in a particular linked list node and just iterates down the list. So it's partially an organizational thing. It will help you write the code in a more organized manner. Another reason that we want to have a sentinel node is it allows us to not worry about null checking. So in particular, the sentinel node, I forgot to draw here, we'll also have a pointer back here. It allows us to not worry about null checking. There are no nulls anywhere in this linked list, right? We have a sentinel. So instead of checking for null, we can just check if we're at the sentinel, basically. So there's no need to worry about null checks. There's no need to worry that, next will ever break, because you see here, we could keep doing next forever and it would just keep looping around, right? There's no need to worry about nulls ever. And nulls and null pointer exceptions are one of the banes of programmers' existences, as you yourself have probably figured out. I'm sure you've already written a method and had it come back and say null pointer exceptions because you didn't check something. You have to add an extra if condition. You don't need to do that anymore with the Sentinel-based linked list. If these reasons seem rather abstract or difficult to comprehend, don't worry about it. I didn't really understand it myself when I took the class or for a while thereafter. But those are basically some of the advantages. And as we write more of these things, and as we begin to write code with trees, which is a very similar kind of encapsulated approach, hopefully it will become clearer. Okay, the next thing we're doing here is basically this is kind of prep for the first part of project 1, where we're saying, suppose we have a doubly linked list with the sentinel. In order to write an add first method, which pointers are going to have to change? So this, let's just write a picture. So let's say we have a list L, and let's just say that the list L is pointing at a sentinel like this. The sentinel is going to have a dummy value. We traditionally do 42 as a Douglas Adams reference. It has a prev, and it's going to have a next. And let's just say that this is a 3-element list. So it's going to have 1, 2, 3 like this. We're going to have pointers that look like this, right? The next of the 1 is pointing to the 2, the prev of the 2 is pointing to the 1, etc. The only ones that are a little weird is, remember that the prev of the sentinel is going to be the end of the list. The next of the sentinel is going to be the start of the list. The prev of the first node is going to be the sentinel, and the next of the last node is also going to be the sentinel. Pointers get a little bit weird, but hopefully it's still readable at this point. Okay, so we want to implement a doubly connected linked list. We want to write an add first method, which pointers are going to need to change. Okay, so let's say we want to add a new element to the start of this linked list. So that might be an element here called 0. It's going to have a prev, it's going to have a next, just like the rest of them. So the next is obviously going to have to point here, and the prev is going to want to point up here to the sentinel. Okay, so the question is asking us now, which of these sentinel pointers, these four pointers do we have to change, right? Okay, so let's just look at all the pointers and see what's wrong with this. There's a lot of pointers here, I know, but let's figure it out. So first of all, sentinel.prev. Sentinel.prev is supposed to point the end of the list. The end of the list did not change when we added something new to the start of it, so we don't need to change it. This one, whoops, so this one we don't need to change. Sentinel.next, however, is different. Sentinel.next is supposed to point at the first element of the linked list. Sentinel.next thinks the first element is this one node, but it's not anymore. It's going to be the 0 node. So we need to do something like this. Oh, this is not erasing. There we go. Where Sentinel.next now points at our new node, basically. So this one does need to change Sentinel.next. So let's look at Sentinel.next.prev. And this is also all before we do the changes. So that will need to change, but we haven't changed it yet. So Sentinel.next.prev is going to be Sentinel.next is this. The .prev is going to be this, right? So remember that the prev of the first element of a linked list is going to be pointing at the sentinel. The 1 is no longer the first element. So this does need to change, right? Because we need this to be pointing backwards at the 0, right? So this does need to change. Again, keep in mind, we're applying all these operations individually, which is why I'm undoing them after I do them. You would need to do both those operations and maybe even keep track of the order, because once you change Sentinel.next, well, now if you say Sentinel.next, it points at something else. Okay, so Sentinel.next.next, we need to change that. Sentinel.next is this arrow here, this pointer, right? And Sentinel.next.next is this pointer. This is just a random pointer in the linked list. I don't see any reason this needs to change. So this does not need to change. In fact, it's only these two things. And you'll see that if we make those two changes, we have this point back here, and we have this point here. This is actually all just fine, because notice the next of the sentinel is now pointing at the first element, but prev is still pointing at the last element. The internal pointers here are all correct. They're all pointing at the next and prev. And then the prev of the new first element is pointing to the sentinel, and the next of the last element is pointing at the sentinel. Lots of pointers here, might look complicated, but there are advantages to doing it this way. And this is also the kind of logic that you're going to have to do in project 1 if you have not begun it already. So that is all you have to do for this problem. I hope this is somewhat helpful.